Welcome to East by West Farm, where we grow what we eat and we eat what we grow. In this video, Haiying walks you through the calculation of the roof trusses and the roof. Difficult things to build in carpentry. You're dealing with all sort of angles that are not perpendicular, and if you don't measure the angles right, the roof just doesn't go together well. So Haiying walks you through the various steps of designing a roof. It starts out with determining the angle of the roof, the pitch of the roof, and goes on to one of the most difficult things, which is the rafter. Those are the beams that support the roof itself. The rafters need to be cut at specific angles so that the roof is straight and plumb. You also need to cut a bird's mouth. That's the cutout where the rafters sit on top of the walls. And then you calculate the overhang and get a smooth edge so that you can put the fascia, the soffits on it without having them hanging out at a very strange angle. With this all calculated, Haiying calculates the total roof of the supporting beam that supports the ridge. None of this is very difficult. It's a little bit of math, really just addition and multiplication. This is also good for other things that you can build, like stairs or sawhorses. So I hope you enjoy it. Let us know what you think and enjoy the ride.
The first thing you want to know is the roof pitch. In US, usually you take the roof pitch to be a multiplier of 1/12. So in this case, I have my roof pitch is 4/12, and that is equal to 1/3. You take both the top and the bottom divided by 4, you end up with 1/3. What I draw over here is the roof pitch. So that means the vertical dimension is 1 and the horizontal dimension is 3. And the math comes in to calculate the length of this triangle. So that is square root of the vertical distance plus the horizontal dimension. So that gives you square root of 10, and that is 3.162. This is the triangle that I will work with, because in this case, the principle of proportional come into play. So basically is if you have this small triangle or like this big triangle, as long as the ratio between the vertical dimension and the horizontal dimension is 1/3, then the triangle will look similar. One of the parameter that is important is the ratio between the diagonal line and the horizontal dimension, and we will use that over and over again. So I will put it down here. So the ratio, I will call it R, is equal to the diagonal line divided by the horizontal, the large dimension, and that gave me 1.054. I keep a few more decimal points over here just to avoid the large round-off error. Another thing, of course, you need to know is the span of the roof. In this case, the span of the roof, or the roof span, is 8 feet, so that gives you 96 inches. And then the run of the roof design is half of the span, because we only consider the left side. The right side is the mirror image of the left side, so we don't need to worry about it. The run is equal to the span divided by 2, and so that gives me 84 inches. Another thing you want to decide is the the ridge board and the riser. Of course, they are the same width. So I will call it the ridge board. And I will use HRB. So RB stands ridge board. And so in this case, I have a 2x4, and I'm looking at the small dimension. So the actual dimension is 1.5 inches. Once you have that, you can start to design the rafter. So the first thing you want to decide is the rafter length. Basically is from this plumb line to the plumb line of the bird mouth. And so that dimension is the rafter length. To calculate that, you need draw a reference line. So I basically take the edge and draw a parallel line from the edge to the end of to the bottom of the bird mouth. So let me use a different pen. Because it's parallel line, so the rafter length is basically the length of this dashed line I just drawn. So now you can use the triangle to do the calculation on the rafter length. In this case, I will draw the triangle. So basically is from here maybe I use don't have a different color of pen. So basically that's the triangle I'm going to use is the dashed line I just draw, the vertical, the left side of the riser, and then the top side of the double header. For that, we don't know this dimension yet, but we know that dimension is the run minus half of the ridge board, which we use HRB. That triangle basically is proportional to this triangle over here. The run minus 1/2 of the ridge board is 48 minus 0.75 is 0.725 inches. That triangle, we know the horizontal dimension is 47.25, and then so the dimension of the diagonal, which is the rafter length, will be proportional to these, right? So what you have is, so let me move this away a little bit. So for that, now we can calculate the rafter length is basically this ratio times the run minus 1/2 of my ridge board width. So that gave me 1.054 times 47.25, and that gave me 49.8 inches. Once you determine that, then the next thing you want to determine is the overhang, and that is your choice, whatever overhang you want. So this is the overhang of your rafter. So let's say, just to make it easy, we will make that 10 inches. Now that we calculated the rafter length and the overhang, we can start to work on the 2x4 to draw the lines for the cut. Since this is a 2x4, that means this dimension is the large dimension that's corresponding to the 4, so the actual dimension is 3.5 inches. The first one line you want to draw is that plumb line that butts against the ridge board. So that line essentially goes something like that. Since this is 3.5, and that triangle basically is 1, 3 over here, so that dimension should be 3.5 divided by 1 to get a ratio of 1 to 3. So 3.5 divided by 3 is 1.17, 1.167, something like that. So that point would be over here, and then if you're drawing that corner with that point, that will give you the plumb cut. But the problem with that, so let me give this dimension for now. So that's 3.5 over 3 equal to 1.16. The problem with that is because you have the rounded edge with the 2x4, you may not find that point easily. The second thing is 1.16 is also not a very good number to work with, especially when you're working with fraction. So what I will do is actually use the right edge as my reference point. And so I can choose a convenient distance like that 1.5. As long as this number is larger than that number, it will work. So 1.5 from here is end up over there. So that will be my starting point of my plumb cut. So all I need is draw a parallel line for that. So of course at this point, you don't have that line. That line I just show you what it should look like. So what you do is you take a speed square and butt against and draw a line that's perpendicular to that edge. You won't have a problem with drawing that line when you have the speed square even with a rounded edge. And then I need to define that plumb line. What you do is actually from that you draw a 1.5 inch mark and a 3 inch mark over there. And then from the 1.3, you draw a perpendicular line with a length of 0.5. So this is 1.5 and this is 0.5. So that gives you a ratio of 1 to 3. The same thing for the 3 inch mark. Then you draw a 1 inch. So that's 1 inch, and then that dimension is 3 inch. And so now you basically have 2 points, this point and that point, and that will give you, define your plumb line. So that's your cut. I will mark and use a different color to show that's your plumb cut. The next step is we want to cut the bird mouth. And for the bird mouth, we will start at this point because we know that from this point to that point is the rafter length. So basically it's from this point to wherever that bird mouth will be the rafter length, which is 49.8. And in this case, I don't have the length in proportion, so I just assume there's a cut over here just to demonstrate. Since I'm using this as a reference line, so from here to the bird mouth is 49.8, and I have also this 1.5 offset. So that means I would just assume this is my bird mouth. So that dimension, I determine that point by measure the dimension from my reference line. So that dimension is my rafter length, which is 49.8. believe so, plus 1.5. So that gave me 51.3 inches. Oh, this is in inches. So I find that point, which is that point of the bird mouth. And then I do the same thing that I want to find the plumb line of the bird mouth. So I do the same thing with draw a perpendicular line. And then I draw the 1.5 mark and the 3-inch mark. And then I do my 0.5 and 1, and that keep my proportion of 1 to 3, and then I can connect those two lines. And that gave me the plumb line of the bird mouth. So of course, now I have to decide how deep my bird mouth needs to be. And for that, it's the bird mouth, the depth of the bird mouth is not that critical because it basically determines how high your rafter is sitting on top of the double header. So you can choose a convenient one, but you do need the dimension of the bird mouth seat to calculate the riser. So usually the depth of the bird mouth is about between maybe 1/3 and 1/2. So I will actually just use the 1.5 line as a reference because so 1.5 compared with 3.5 is less than 1/2 and more than 1/3. So that's a good dimension to use. I just use that and then I draw my reference line here is a little bit too close. I remove that for now. Now I have the plumb line and I choose 1.5 and then I can draw the perpendicular line for that. So this will be my bird mouth seat. And then of course my cut line is over there. For that, as I said, we will need this dimension, so we may as well calculate it. So let me draw the cut line. So your cut line will be from here to there. So to calculate that length, you have, I know 1.5 over here, from here to there. So again, this is one. So that again is the ratio, the triangle. So that means this line is 1.5 times the ratio 1.054. And that gave me 1.581 inches. And then to calculate that, now I have this dimension and I know the ratio is 1 to 3. So I take that number times 3 and that gave me 4.74. So that's 1.581 times 3 is give me 4.743. Of course, that is 4 3/4 is roughly pretty close to 4 3/4. The last cut, or second to last cut, is the tail of the rafter. Now I have this dimension over here based on that. And now I have another, the tail basically is parallel to the bird mouth, so it's at this 1/3 angle and it has an overhang of 10 inches. I'm going to measure from my reference line. So if I extend this a little bit more, and that, so we get up to here. And that dimension is 51.3 plus 10, that's my overhand, and that gave me 61.3 inches. So you measure from here to there, 61.3 inches, and that gave me the end of that plumb line. In this case, I will just do parallel because it's just repeating itself. So it's faster to just draw a parallel line. So that's the tail of the rafter. So you make that cut. Your rafter will be looking like this. And over here I can. This wiggly line just means that there's a length over there. So I kind of showing the left end or right end of the rafter. At this point, you could end it here, or if you want to have a fissure, and then you want to have a cover board underneath the rafter to cover that, and then you may want to cut that line that is perpendicular to the overhang. If you want to do that, then you need to determine that dimension of your tail so that you can decide where that line would be. That I call it that tail height. So that dimension, I will call it tail height. H-E-I-G-H-T. To calculate the tail height, you need to take quite a few things into consideration. So what I show over here is kind of like a broad up view of the tail end of the rafter. So what I have here, this is the deck, roof deck. And this is the fascia. And then there's a technical name for that. I just call it the cover. In this case, I assume the cover is flush with the fascia. This is my rafter over here. Assume I have a 2x4 or 1x4 for the fascia, so I can assume that height is 3.5 inches. And the deck board is, the thickness is assumed is to 0.5 inches. The same thing with the cover board is 0.5 inches. If you look over here, is that dimension from here to there of the roof deck plus the tail height of the rafter plus the thickness of the cover is going to equal to the facial board width, which is 3.5. So I draw that line. So that's the tail height we want. I can write down the equation. There's another thing. We know that this dimension is 0.5 inches. So that dimension is, again, you use the triangle. So this is 3, and that's the ratio between this and that is 1.05. So it's 0.5 times 1.054, and that gives me 0.527 inches. That dimension, of course, is just the thickness of the cover board. So that gives me 0.5. So now I can say that my tail height is equal to 3.5 minus the length of the deck board, which is 0.527, minus the thickness of the cover board is 0.5. That gives me a little less than 2.5. So that gave me 2.473 inches. So once I have that dimension, of course, then all I need is come over here and so that's almost 2.5, a little bit short of 2.5, and I make a perpendicular line over there. And of course, this length is proportion. This is not so close to the bird mouth because this length is not 10 inches because I have limited room over here. So that dimension is my tail height is 2.473 inches. So I probably should put a wiggling line over here to show that it's not really so close. That basically is the rafter you have. So you have essentially 5 cuts, the plumb line butting against the ridge board. The bird mouth have 2 cuts, and then the tail has the plumb line and also the horizontal line that for the cover. That's the calculation you will use to calculate the dimension of your rafter. All the calculation is based on this triangle, 1, 3, and then the ratio between the diagonal line and the horizontal, that's 1.054. Once you have that, you can use this triangle. All you need is find the triangle similar to this, and then find the dimensions. Once you cut the rafter, there's another dimension you need to decide is the riser, how tall the riser you need, board needed to be. So for that, we come back to this big picture over here. Usually the riser has basically, this is your riser board. And then you sit on, have another 2x4 sit on top of it. The ridge board have a dimension of 3.5 inches. We need to determine that the height of the riser. You will use a triangle starting at that point, which is the end of the bird mouth seat, and go down. So that's the triangle you will use. So the first thing is we want to find that dimension, and the riser will be just slightly above that. That dimension, I will just give it random symbols so it's easy to calculate. So that's the H. In this case, we know from that dimension to the bird mouth, so from the edge to the bird mouth, that is the run minus 1/2 of the thickness of ridge board. We already know that. So that dimension is over here. This dimension, then, if I draw down here, will be that dimension and the minus the seat of the bird mouth. So we will know basically the horizontal dimension of that triangle. Since that triangle is proportional to this triangle, then we know that H is 1/3 of that. We can write down H is 1/3 of the run minus 1/2 of the ridge board thickness and the seat of the bird mouth. And so we know the run is 48 inches. The ridge board is 1/2 of the ridge board is 0.75, and then the bird mouth seat we calculate is 4.743, and so we can calculate that. So that gave me 14.2 inches. Then the total ridge height is that dimension I just calculated. So that's that dimension plus the height of the rafter board, but it's at an angle. So basically it's the length of the plumb board. So again, I can calculate, use triangle. So the rafter board is 3.5 inches in height. And then, so that will be 3.5 times 1.04. So that will be H plus 3.5 times 1.054. And so that gave me 17.9 inches.
Thank you very much for watching. I hope that was useful. If you have any comments and suggestions, please leave them in the section below. If you like this video, give us a thumbs up. In the next video, we will show you a spreadsheet-based calculator that can do much of the calculations that we just presented automatically. If you want to be updated on what's going on at the East by West farm, please hit the subscribe button. If you want to follow us, visit our Facebook page and subscribe to our Facebook.